Good afternoon, one and all present here. Let's start the topics of prestressed concrete. The concrete having three types. So first one is normal concrete. Normal concrete is the combination of cement, water, fine aggregate and coarse aggregate. It is a PCC type. So used for pavement, buildings and floors. Usually strength obtained for 20 to 40 MPa. Then RCC concrete. The RCC means the steel is reinforced in the concrete structure. So it is the RCC. RCC is used for normally for all construction for the purpose of apartment buildings, or this having the maximum compressive strength obtained 40 MPa. Then continue to the three types. This is the normal PCC, RCC and prestressed concrete. The prestressed concrete having maximum strength for uptime using high strength concrete and high strength steel. High strength concrete means the minimum grade of concrete is M30 for free force tension and M40 for free tension. The steel, what is mean by prestressed concrete? The steel tension or free tension before concrete is poured. Normally concrete is first the concrete is poured, then steel is induced into the RCC member. This is a normal DRC concrete. So the DRC means post tension concrete. The prestressed nowadays using the prestressed concrete for large span requirement building. Example bridges and railway tracks using the prestressed concrete. Though the main part is the steel tension is used for the prestressed concrete. What is mean by tension? The tension is the group of wires. Wires mean steel. The group of steel is induced in a combined and for one steel. And the yield strength of the tension is minimum 1200 to 2400. Next, what is the purpose of prestressing concrete used in the construction? It resists the tensile stresses better compared to RCC. Then is used for long span bridges and girder. Okay, wow. So first all of you noted that normal concrete, RC and difference between prestressed concrete. Then first is maximum only for the strength of the prestressed concrete is aligned. So strength means the concrete having compression, the prestressed concrete having maximum compressive strength compared to PCC and RCC. And normally PCC having maximum compressive strength is 15 to 25 megapascal. RCC reinforced cement concrete maximum compressive strength to 20 to 40 megapascal. Nowadays using prestressed concrete having the maximum compressive strength of 40 to 80 megapascal or Newton per mm square. So this is the comparison of three types of concrete having the maximum strength. So first of all introduce about prestressed concrete material used for prestressed concrete. Cement also already OPC is normally used for RCC building in the conforming of IS 269B. Plus included some Portland slag cement conforming IS 455. The slag is the steel waste. The steel waste is not more than 50%. It is used for the prestressed concrete. This is the steel waste producing the steel company. So there is next one, rapid hardening Portland cement using the prestressed concrete from IS 8041 conforming. Then this is the cement. Then what type of steel is used means high tensile steel. High tensile means high yielding compressive strength, high yield strength. So normally RCC only used for mild steel and HYST. HYST means high yield strength deformed for 415 used normally RCC building. Then prestressed concrete having the yield strength 1200 to 2400. So maximum group of steel is combined. One wire is considered. This is the tension. So the tension is maximum used for this prestressed concrete. The steel conforming the IS code of 1785 Part 1 and Part 3. Next, cold trap indented wire conforming IS 6003. High tensile steel wire bar conforming IS 2090. This type of steel used for this pre-stressed concrete members. Okay. Next, the common terms used for pre-stressed concrete members. Commonly material used for the pre-stressed concrete member. First one is tenton. Tenton is the group of wires. What is mean by wire? Wire is the steel. One single steel is a wire. The group of steel is the tenton. So the group of tentons is named as cable. Okay, this is the comparison of tenton, wire and strand. Then next one, this is the normally precasting mode of prestressed concrete. Prefabricated structure, normally used for prefabricated structure or precast concrete structure in a fabrication unit. The Madras, Chennai having one fabrication unit. This is the fabrication unit. Fabrication unit having this type of format. So the wires, strands and tentons, this is the examples of wires. The pre-stressing wire means single steel, single unit made up of steel. This is the wire. The strand means 2 or 3 7 wires are found in a pre-stressing strand. So single wire means single steel means wire in terms of wire. Strand means 2, 3 or 7 wires conformed to get the pre-stressing strand. 1, 2, 3, 4, 5, 6 or 7, or sometimes using 2 or 3 used for the strand. Then this is the tenton. Tenton is the group of strand or group of wires. So also known as tenton. Tenton is very important for pre-stressed concrete structures. So the tenton can be made up of single steel core. The diameter of core is much larger than the wire. So wire is the single unit of steel. Tenton is the group of steel wires composed each tenton. One tenton having group of wires minimum 2 or 3 or 7 wires. How is it work? Pre-stressed concrete, how is it work that? What is mean by pre-stressing? So pre-stressing means the high strength steel tenton. High strength steel tenton is a cables, wires or strand is known as high strength steel tenton, are tension and anchored against the concrete before subjected to external load. So this is a normal concrete. This is a normal concrete, is the RCC concrete. First concrete is poured, then steel is induced the concrete member. It is the post tension. So pre-tension means first the steel is tension, then after that the concrete is poured in the member. Then they cut out the steel and this induce the stress in the concrete to balance the deflection. So deflection is very small compared to RCC and PCC. So normally used for pre-stressed concrete for large members. Then the counteracting forces, this is the principle. Principle means balance, load balancing concept. So counteract the two forces, it's the pre-stressed concrete is working. So how to counteract the forces? The tension create tenton before concrete, before poured the concrete. This is the counterfooting forces. The tension create the compressive stress within a concrete. When the structure is loaded, this compressive stresses help absorb the tensile stresses that would normally develop and preventing cracking and increasing the load bearing capacity. So the tenton is the group of wire, is induced in the fabrication unit first, then concrete is molded on the beam. So the pre-stressed tenton having upward deflection, normally self-weight and live load getting the downward deflection. So the two deflection is counted for the balancing the section. So balancing forces acted on the pre-tensioning. So this is the pre-stressed concrete. So two method of pre-stressing normally, real world application normally used the method of two method of pre-stressing. First one is pre-tensioning, second one is post-tensioning. free tension. So free tensioning means before concrete placed the tension in member. This is the free tensioning. So the tension or tension before the concrete is placed. The concrete bond to the tension is cured, transferring the tension force to the concrete. So concrete having compression, some amount of tension, steel having tension. So to release the tension, they induce the tension to the concrete, so counteract the forces. So pre-tensioning is a very important method. So used for this nowadays using the pre-tension is a very important one. The minimum grade of concrete for pre-tensioning is M40. Post-tensioning having M30. Post-tension means normally RCC structure. First tension after the concrete have hardened. First concrete is poured into the mold. After curing, after that the tension induced through anchors or jack. Induced through anchor and jack. They are typically placed inside the duct or inside any cable and induce the steel. Then stressed using the specialized equipment, hydraulic jack. Specialized equipment, hydraulic jack or electrical equipment used for post-tensioning. So post-tensioning means first concrete poured, after this tension are induced. Pre-tensioning means first tension induced tension to the member, then after that concrete poured into the place, so counteract the balance, so no small amount of losses are occurred in pre-tensioning. Next one, this is the method of pre-stressing difference. This for pre-tensioning. Pre-tension means first induce the tension, after that concrete is poured. Post-tensioning means concrete is filled. This is the field type using the fielding. This is the fabrication unit. Post-tensioning using in field site work. This is the having the more amount of fabrication into upward. Post-tensioning is only for field work. So first concrete slabs or column and making, then after that inject the tension using the cables, using the duct and anchorage. So this is the post-tensioning, this is the pre-tensioning method. So pre-tensioning means first the steel are induced to the concrete. So the changing length, what is mean by steel having the tension? So changing length and original length does occur. So changing length means elastic deformation. Normally consider for rubber, those are rubber is extended, then having after release the forces, after that you get the original position. Same principle applied in the pre-tensioning members. So loss of elastic is occurred. Post-tensioning, the no loss due to elastic deformation. No loss due to elastic deformation. However, the concrete is made it after the steel introduced, so no elastic deformation does not occur. Okay. Next, this is the tension profile. Load balancing concept of prestressed concrete is very important to prestressed concrete members. So this first one is unstressed beam. Unstressed means the load is not acted. Then the load is applied, you getting the downward deflection. Then tension is stressed. The tension means group of steel is induced to the member, and free stressing forces acted. The release cut down the steel and release the steel. You getting the free stressing forces after having the upward deflection. So free stress is having upward and force stress having downward deflection. The load is applied is the downward deflection and free stress is the upward deflection. So counteract the two deflection, the total deflection is flat. This is the tension profile. This is used for prestressed concrete member. It is the load balancing concept. It's clear that this is the tension profile. The beam is the unstressed beam. Then load is applied. The load is applied means it having the downward deflection or self-weight or live load as actor. The beam having self-weight or live load. Anybody acting, the load having to going to downward deflection. Then tension induced, release the tension, you get the upward deflection. The total deflection is flat. So So this is the tenton profile. So first, so to induce the stress, first of all is making the concept of the pre-tensioning. The pre-tensioning is first induce the steel to the concrete. So types of deflections are occur: short term and long term deflection. What is mean by short term? Short term means the load is applied after that the beam or deflect after 1 minute or after 1 hour. So getting the short term, within the short term getting the deflection is known as short term deflection. The long term deflection is after 1 year or after few months getting deflection to the beam members or slab member is a long term deflection. The types of deflection of prestressed concrete member is two. First one is short term, second one is long term. Short term, the example of short term means first the stress is induced to the steel member. So release the stress, you get the elastic deformation. So changes the steel length. It is a short term deflection. You induce the stress, release the stress, and some changes are occurred in the steel member, tenton. Some changes occurred, increase or decrease, or some changes are occurred. This is the short term deflection. Long term deflection means after few months or after 1 year, due to temperature, due to weather conditions, it's occurred the creep, shrinkage. This is the long term deflection. Okay. So first one is short term deflection. The short term deflection due to free stressing force. What is mean by free stressing force? Free stressing force, the stress. So stress is equal to load by area. The load is the applied is the free stressing force due to the steel member. So the steel is the tenton. The force induced to the tenton means the free stressing tenton. So it having the name of free stressing force. Then short term deflection due to three. First one is free stressing force, second one dead load, third one live load. So the free stressing means the induce the tenton, so having the free stressing force, having short term deflection. Then dead load. How to calculate the dead load? So the dead load calculated from unit weight of concrete into member area. So unit weight normally taken 24 kilonewton per meter cube. Then the rectangular beam also considered. So breadth into depth is the area. So unit weight into breadth into depth, getting the dead load. Then live load. Live load is the external applied load, is taken 2 or 4 from IS code 456 from the consideration of the member. Next one, the long term, short term deflection due to only 3 members: free stressing force, dead load, live load. So dead load deflection, how to calculate the dead load deflection? It is a simply supported beam means the dead load formula is 5 by 384 WL power 4 divided by EA. Then how to calculate the live load deflection? The live load deflection is already calculated the dead load and free stressing deflection. So the dead load deflection is 5 by 384 WL power 4 EA, you got it. Then applied the live load deflection is sulfide deflection divided by sulfide into live load. So getting the live load deflection. How to calculate the free stressing deflection? Free stress is the upward deflection. Dead load and live load is the downward deflection. So the upward deflection having using with preference of what type of tenton are used. Suppose a straight tenton is using the formula of PEL squared by 8TA. Suppose using the parabolic tenton means the formula of deflection of free stress is 5 PEL squared by 48 EA. E is the Young's modulus of concrete, normally taken 35 or 38. Then I is the moment of inertia. Moment of inertia is PD cube divided by 12 for rectangular beam. So 3 types of deflection calculator for the short term deflection. First one, free stressing deflection. It is related to how which type of cables are used. Straight cable means PEL squared by 8TA. Suppose using the trapezoidal tenton means 5 PEL squared by 48 EA. Then using the trapezoidal means normally this is the which type of tenton using this, the formula is varying. Dead load is the common one. The self weight is added to the dead load. The formula is 5 by 384 WL power 4 divided by A. Load normally taken as 2 or 4 and calculate the sum of the two deflection and overall short term deflection is calculated. So clear that. Next one, long term deflection. Long term deflection. What does mean by long term deflection? Long term deflection is the some times are occurred, then after that the cracks will be formed or deflection will be formed. The crack form as this compared to RCC is only small amount of deflections are occurred in prestressed concrete. So preferably you take the prestressed concrete for nowadays bridges, long span structure using the prestressed concrete. So long term deflection means after few months or after 1 year the beam structure, prestressed or frame structure having the cracks, normally due to creep of concrete, stringage of concrete, relaxation of steel and long term dead plus live load. So first one is creep. The creep of concrete. The creep is the creep means is a constant load applied over the time. Okay, but the creep is the constant loading applied over time. Over time means some few months or some years. So creep is the gradual, is the time dependent, is when subjected to constant load over time. So you getting the creep deflection. Example, if you place a heavy object on a concrete beam, let's leave for a month or 5 months or 10 months. After that the beam slowly sags downward. Through load has not been changed. The load is constant. Sometimes or extended to getting the grip. So it is the time dependent one. Okay. Next one, string gauge. String gauge also the long term deflection. So the string gauge is the reduction or decrease the volume of the concrete, is the loss of moisture. So the concrete getting low moisture content means the string gauge is occurred on the beam. So this is the string gauge. String gauge is the reduction in volume of concrete as tries and product due to loss of moisture. So example is like the sponge. The sponge strings when it tries, the concrete will contract is the contraction occur. Especially during the first few weeks after placement. So the concrete is poured after placement, getting the string gauge. So the grip, first one is grip, second one is string gauge. The grip, the calculation part of the grip is, the grip formula is pi into alpha E into Fc. What is mean by pi? Pi is the coefficient, grip coefficient. Alpha E is a modular ratio. Modular ratio formula is Young's modulus of ES by EC. Young's modulus of steel divided by Young's modulus of concrete. Young's modulus of steel having the value of 210 kilonewton per meter square and Young's modulus of concrete is 38. So 210 divided by 38 having the alpha E value 6. So grip of concrete is calculated by the formula of alpha E Fc into pi. Okay, pi is the grip coefficient. Fc means the concrete stress. Concrete stress formula is included direct stress and ascending stress. This direct stress is the P by A, ascending stress is the P into E into E divided by I. So this formula using to calculate the grip of concrete. Then string gauge. String gauge is also calculated from IS code book 1343. So the string gauge value of the two values are taken. Free tension means the string gauge value is 200 into 10 power minus 6. Or using the post tension concrete means the string gauge value is 300 into 10 power minus 6 you taken from IS 1343. Next is relaxation. So relaxation is the reduction of stress in tenton over time. The reduction of strength in tenton over the time without any changes in strain. So examples already you know that. Imagine the stretching the rubber band tightly, after the loses the rubber, his ends are held fixed. This is the relaxation. So the long term deflection having grip, shrinkage, relaxation. Okay, short term deflection having pre-stressing comb, dead load, liability. This is the deflection. So the deflection is occur come for losses will occur. So deflection occurred to any number and losses also occurred for this number. So first is deflection occur, then losses are occurred. Next going to losses of pre-stress. Losses of pre-stress. The pre-stress concrete having two methods, pre-tensioning and post-tensioning. So pre-tensioning means first steel is induced, then concrete is poured. The losses are different. Post-tensioning means first concrete is hardened, after that the steel is induced through jack or anchorage. So post-tensioning concrete member having some types of losses, pre-tensioning having some types of losses. Okay. So first one is elastic. Elastic is the pre-tension. Okay. Elastic deformation, how to find out that? The pre-tension. So some take the steel tendon, so stress the steel means the elastic is occurred, changing length is occurred. This is the elastic deformation loss. So the pre-tensioning having the elastic deformation, but post-tensioning having no loss due to elastic deformation. Whenever the steel is applied after the concrete is poured in the applied, so no loss occurred on elastic deformation. So pre-tensioning only having the elastic deformation, post-tensioning not having this type of losses. Okay. Then next one, this is the elastic deformation is the first one. Next one is creep. Creep, although deflection creep are occurred, plus the creep losses are occurred. Okay. Then shrinkage also the deflection may be occurred due to shrinkage, and also some losses are created to the shrinkage. Then relaxation. So the deflection is also compared to the losses having the same one. Only some losses are occurred during the deflection. Next is the post-tensioning losses. Post-tensioning losses. The no losses due to elastic deformation. The steel is induced after the concrete is hardened, so the elastic deformation is not occurred. After the concrete is hardened, using the jack through the cable, so not having the elastic deformation, only through the steel is induced only friction and anchorage slip losses occurred. So the post-tensioning having extra losses of friction and slip. These three losses are common for pre-tensioning and post-tensioning. The no slot due to elastic, creep, shrinkage, relaxation is the common for pre-tension and post-tensioning. Friction and slip is the only losses occurred for post-tensioning member. So the friction is the after concrete is poured, the steel is induced, so friction is occurred on this type of post-tensioning member. And slip using the anchorage using the steel is induced, so the anchorage slip are occurred. This is the loss of post-tensioning losses. So short term deflection, long term deflection, then pre-tensioning losses and post-tensioning losses are explained. Next is the creep, the factor and the effect. So the factor affecting the creep is the grade of concrete. The grade of concrete means M20, M30, M40, etc. So grade means compressive strength of concrete. M20, the 20 is the compressive strength. The 28 days after compressive strength, the cube mode having the 150 mm, after 28 days you testing on the UTM, get the grade of 20 or 30 is taken as the grade of concrete. So this is the compressive strength of concrete. So using the higher grade, the creep is less. Higher grade means the minimum grade of pre-stress is M30. So using higher grade means less creeps are occurred. Then age at the loading. Older concrete means less creeps are occurred. The stress level. High compressive stress is more creep. Then humidity, low humidity, more creep. Size and shape. So the thinner section of the beam section having the more creep. Curing qualities. The better curing having less creep. Is also common for RCC concrete. Then the application of pre-tension concrete. This is the application. So this is the under the compressive strength, then using the structures. So up to the 50, up to 90% using the railway sleeper. Free tension concrete using mostly for railway sleeps. 90% mostly used for railway sleeper and 85% used for precast beam and girder using the bridges. Okay, then 80% roof slab or floor slab, flat slab, same also used for bridges. Long span is the above 30 meter, it is notated as the long span. The long span normally used for bridges. 80% of free tension concrete using the roof slab member, then 70% using the electric pole, 75% for bridge deck panel, 60% of prestressed concrete using concrete pipe. Okay, then 55% for wall panel, 50% used for the marine structure. This is the application used for this construction. Then next one, advantages and its application. So the free tension is a factory made. This is not a site work. This is the factory made. Only you make a concrete member and set on the site work. So the time is will be less compared to RCC. So this is a factory made, high quality and uniformity is acquired. Then faster deflection. Fabrication unit only some beams and columns are you make them. Next you only fit on the site. So is short and construction site. Then lightweight. The prestressed concrete having lightweight, so reduce the transportation cost, durable compared to RCC, long service life and low maintenance. So this is the advantages in application. Then application of post tension. Post tension means normally for RCC, first concrete is poured, then steel is induced to using the anchorage. This is normally using same bridges and flyover, long span with fewer support, efficient for highway, river and valleys, then high rise building, thinner slab, fewer column, more usable floor space, parking structure, large open base for easy vehicle movement and long span without trapping. The next one is, this is the real part of the prestressed concrete member. So this is the soil foundation, then compacted the substrate, then poured into concrete, and this is the reinforced rebar support, post tension cable, the track surface. So the railway uses. So first one to revision for the first slide. Types of concrete. Types of concrete mean PCC used for M20 concrete. Okay. Next, three types of concrete are the PCC, RCC, prestressed concrete. Prestressed concrete mostly used for the long span structures, normally bridges and railway tracks using that. Okay. Next, this is the compressive strength comparison for PCC, RCC and prestressed. RCC having more compressive strength compared to PCC and RCC. Then material used, the cement is used for Portland slag cement. Slag is normally less than 50%. The steel is a high tensile steel conforming IS 6003. Next, common terms is tenton wire strand cables. This is the diagram of the wire. Wire is the single steel, strands is the group of steel, tenton is the group of strand, then tenton made from single steel wire. How does it work? The two methods working, pre-tensioning and post-tensioning. Counteracting the folders, load balancing concept is used for the pre-tensioning. So pre-tension is having the fabrication unit only made up of skilled labor is wanted. Post-tensioning is a site work. First normally concrete is poured, then induce the steel using the anchorage and hydraulic jar. So this is the difference. Pre-tensioning, post-tensioning. The tension profile. The load is applied, the deflection downward is occurred, then tension is stressed, release the tension and getting the upward deflection. The total deflection is flat. Counteract the forces. So So type of deflection is short-term deflection, long-term deflection. Short-term deflection only after load is applied, instantaneous deflections are occurred due to prestressing force, dead load and live load. Dead load calculated from the formula 5 by 384 884 divided by E8 for simply supported. Then live load is from code book. Prestressing force is using for the types of tendon are used. The straight tendon is using PEL square by 88. Suppose parabolic cable is used, 5 PEL square by 48 ES. Then long term, due to after 1 year, after a few months, the beam getting the deflection, the grip occurred and stringage occurred, relaxation occurred. The grip is very, very important one. The grip coefficient is a long term process. Over time, the grip considered is much more than these stringage and relaxation. So this is the grip factor and this effect. Then application is very, very important. 90% used for railway sleeper, 85% used for precast beam and girder, then 70% for electric fold, 75 bridge deck panel, 60 is the concrete pipe, 55% for wall panel, 50% for marine structure. So application same is a real application, what is the how to apply this structure is first is soil foundation, then compacted substrate, then concrete, then plastic for the reinforced piece support. So thank you.